Your eyes aren't deceiving you. A second major magnitude 7 earthquake occurred late yesterday, completely unrelated to the deadly intraplate Philippine quake sequence. As, at 5:29 p.m. local time on October 10th, a major magnitude 7.6 earthquake struck the Drake Passage between the southern tip of South America and the northernmost point of Antarctica, representing the fourth largest earthquake to strike in 2025 so far. And while I do not have an official duration measurement to go off of, the ground during this earthquake likely shook for upwards of 50 seconds. Due to its absurdly remote epicenter in the open ocean, only a few hundred people at most felt this absurdly energetic event, either on various scientific bases in northern Antarctica or on the very southernmost remote parts of Chile and Argentina. So, while the strongest ground shaking anyone felt is shown in this simulation, quite weak and unable to cause damage, this second simulation shows what would have happened if the epicenter of this quake was instead beneath the densely populated region. Just be glad this is quite remote. And if this video is giving a few members of my audience a sense of deja vu, you aren't crazy, because on August 21st, 2025, a magnitude 7.5 quake struck a mere 5.2 miles or 8.3 kilometers to the east of this very spot. And while that earthquake ended up generating a regional, albeit very low height tsunami of 20 centimeters or less, the more recent quake did not generate any form of a tsunami. This begs the question, why was there no tsunami? After all, there were two similar magnitude events in essentially the same location with a similar rupture distance involving the same fault type, a right lateral strike slip fault. This means the motion that occurred was almost purely horizontal rather than vertical, with the right side of a fault from a straight-on view down its length moving towards the viewer during an earthquake. Well, while these two earthquakes were nearly identical for all intents and purposes, there was one notable aspect that made a huge difference. The August 21st earthquake, despite its lesser magnitude, ended up producing about 4 times the amount of vertical motion. And this is because the August 21st quake involved a fault plane with a dip of 69 degrees, while yesterday's October 10th quake involved a fault plane with a dip of 85 degrees. In other words, the latter was almost a perfect strike slip quake with very little vertical motion. Regardless, why did these two earthquakes occur in the first place in such close proximity? I suspect that they were a delayed doublet, and am interpreting that a large strike slip fault failed to rupture fully due to some blockage or mass that impeded fault movement on August 21st. Thus, what would have otherwise been a singular magnitude 7.76 earthquake later occurred as two separate lesser magnitude quakes. But this is just my hypothesis. However, yesterday's quake was quite special. It represented the largest earthquake to strike in the interior of a tectonic plate and not at or near a tectonic plate boundary since 2016. Now, while I must stress that the low-resolution seafloor data is not trustworthy if you are looking for finer detailed structures, as it can create the appearance of features that don't actually exist, or ones that do exist are just missing, I actually think I can spot a north-northeast trending fault here, which I have outlined. While some people have speculated that such a fault line, if it exists, might be evidence of a newly forming tectonic plate, I instead interpret the opposite. This is evidence of a dying tectonic plate which will soon, geologically speaking, be completely destroyed. As, what I have outlined in green, represents the last surface remnants of the Phoenix Plate, a tectonic plate that during the late Jurassic period, during its greatest extent, was about the size of the entire modern Indo-Australian Plate. Yet today it exists as part of the Antarctic Plate, although large fault lines that previously formed within still remain as weak points. Thus, through the combination of strain generated by the motion of other nearby tectonic plates, it can build up and then generate large intraplate earthquakes. I hope that you found this video interesting.